In this module, we are going to build a vending machine in NI LabVIEW using state machines. First of all, let us go to the problem statement to check what we need to build. We need to develop a fully embedded vending machine on NI myRIO, and the interface of the vending machine is as follows. So let us go ahead and check what do we need to build in terms of controls and indicators. First of all, we need a message panel right there in order to display what is happening to the user and prompt him or her for an input. Second, what we need is a numeric input in order to be able to insert an amount of money into the machine to be able to buy coffee, milk, tea, or water. And for that, we need an insert money. So the first task is to type in here a certain amount of money in Lebanese pounds, and then click on the insert money button in order to transfer this amount of money to the balance. Now there is one restriction here that the user should input multiples of 500 Lebanese pounds into the numeric control right there in order for it to be accepted by the machine and transferred to the balance. Now we have four options. The user can dispense coffee and it costs 1,500 Lebanese pounds, milk, which costs 1,000 Lebanese pounds, tea, which costs 500 Lebanese pounds, and they can dispense water, which is for free. Now, during the dispensing process, we need to have corresponding LEDs for each of coffee, milk, tea, and water. For example, if the machine is dispensing coffee, this LED will light up, indicating that coffee is being dispensed. And at the same time, what we need to do is to communicate the status of this LED, for example, to NI myRIO in order to show physically the LED. So what we have here is the NI myRIO, and again it has four LEDs, LED 0, LED 1, LED 2, and LED 3. So with these, we can control them directly by communicating between the host PC and the NI myRIO. And we will see as well how we can communicate the data back from the myRIO to the host PC through the push button of the myRIO. Now for the return here, we have one return balance button. And for this one, the user can get their change back once they are happy with their order. And for that, we need a button. Now, what we are going to do is to have two options here. They can either press on the virtual interface on the host PC in order to get back their change, or the user can directly go to NI or to the NI myRIO, click the button right there, the push button, in order also to get their change. So we will see how we will build such capability in the program that we will build using LabVIEW. Finally, we have a stop button for the machine to be able to shut down. So in case the operator needs to shut down the machine, he or she can just press on the stop button and the machine will go off. Finally, we can have an initialization LED telling the user that the machine is being or prepared for to take their order. And this is also pretty nice because it's an indication for the user to know what to expect from the machine at a certain moment in time. Now, what are the requirements for this module? We need to draw, first of all, the state machine diagram for the application. Then we need to build the application on the PC or host PC. Also, we need to build and deploy the application to the NI myRIO, and for that we will build a real-time application. And by that, what we mean that we don't need, after we build the PC application and deploy the NI myRIO application, we don't need to open LabVIEW. We can just open our application just as any normal desktop application, and whenever we connect the myRIO or power it up, we know that the code will run automatically on it, our code, and then we can communicate between the host PC and the NI myRIO. Now we're doing it through the USB cable in this scenario, but in other projects, we can easily do it through Wi-Fi. Perfect. So this is it. So the first thing we are going to go through is the state diagram of our state machine to understand what we need to build in terms of the code of the machine. So the first thing we will need for our state machine is an initialization state slash reinitialization, because what we need to do is to first initialize the machine once it's on, and once an order is taken and a user is done with their order, we need to reinitialize the machine in order to process another order or transaction. So whenever we initialize our machine, we need to make sure that we clear the amount and balance for our machine. For example, right here, after one transaction is done or one order is taken, and the user is happy with their order, what we need to do is to clear the amount and clear the balance in order to prepare our machine for its next order. Then we are going to jump from the state machine is going to jump from the initialization to an idle state. In this idle state, what we will do is we will wait for an input from the user in order to know what to in order to be able to process their order. In other words, the first step or logical first step is to insert money into the machine. So in the idle state, we'll wait for an input, a numeric input, which determines the amount of money inserted by the user. And for this input, it must be a multiple of 500. So whenever the push button for the insert money is pressed, what we need to do is to go directly to the insert money state and update the balance right there if the amount is a multiple of 500 and greater than 0. If not, what we need to do, we need to prompt the user that the amount is not a multiple of 500 and not greater than 0, or just not a multiple of 500, and then we'll go back quickly to the idle with the message displayed that the amount of money is invalid. Okay, so they need to insert again or reinsert a valid amount of money. Now, once they insert a proper amount of money, they have the option to go for coffee, milk, tea, or water. So what we need to do here, we need to first of all have four buttons, as you can see. So we have the coffee button, milk, tea, and water. Now, the first thing we need to do in the idle state is to check the balance. For example, if the user, he or she is interested in getting coffee, we need to make sure that the balance right there is enough for coffee. For example, it needs to be greater than or equal to 1,500 pounds. So for that, we need to check there. If the amount is larger than 1,500 Lebanese pounds, then that's great. We will proceed to the coffee state and we will dispense coffee for 5 seconds. If not, we need to prompt the user that the amount of money is insufficient or there are insufficient funds in their account and back to idle. And the same thing applies for the state of milk, tea, and water. Now, in our scenario, we will dispense coffee for 5 seconds and turn the LED 0 on the myRIO on to indicate that state. For milk, we will dispense it for 4 seconds and we will use LED 1 to indicate the state. For T, we will dispense it for 3 seconds, and we will use LED 2 on the myRIO. For water, we will dispense it for 2 seconds and use LED 3 for on the NI myRIO. Now again, the LEDs here are just indicators, but in a real project, what you will have actually is some sort of actuators that you can actuate based on the option or the dispensing process. For example, if I want to dispense coffee, you need to turn on some motors or play with some mechanisms, okay, in order to be able to dispense the coffee. So you can think about it like you need valves, you need coffee containers, etc. Now we have one more button, which is the return balance button. Now for this return balance button, once this button is pressed, we'll go to the return balance state. Now, if the balance is greater than 0, we will return whatever is available to the user. If not, we will prompt the user that the balance is 0 and there's nothing to be returned. And once this state is executed, what we need to do is to go back to to the initialized state, and in other words, reinitialize our machine. In other words, we need to clear the amount and balance again, and of course, wait for another order. Finally, we have the stop button right there. If we stop it, okay, we'll directly jump to the stop machine state, and this simulates the machine being shut down. And that's it for the state machine diagram. One note here that in LabVIEW, you can either opt for a classical normal interface, or you can opt for a much modern and flat interface. So it's up to you. Of course, it depends on you. You design your machine the way you want because this is your product, and you need, of course, to always take your customer into consideration. So here we have two interfaces. We have the classic one and the flat one. So let us go ahead and start building our code. So the first thing we are going to do is to create a myRIO project. And then here we're going to call it vending machine. And we're going to go ahead, save it on desktop, the vending machine in our current folder, and create our project. Now let us build our state machine under the host PC. Since this is the place or the target underneath which we want to run our state machine. And then we want to communicate whatever data we have from on the host PC back to myRIO. So the first thing we are going to do is, of course, to have our front panel in front of us and our block diagram. Perfect. So now what we're going to do first is to define our states. So for that, we can bring an enum. Here we can call it states. And inside this one, we can add all of our states. So the first one will be initialization or reinitialization. So we can call it initialization, re and initialization. We have the idle state. We have the insert money state. You don't need to just insert money. Also, what we have is dispense coffee. We have dispense tea or milk first. Dispense tea. Dispense water. Return balance or change, up to you. And finally, stop the machine. And there you have it. We have 9 states in total since the index of the first state is 0. So let's go ahead and double check that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 states in total. Perfect. Now we have our enum and it's defined. So what we are going to do next is to go ahead to our block diagram and build the basic block for our state machine. So what we need is, of course, a while loop, and inside this while loop, what we are going to have is in case structure. Then I'm going to right click on the states, create a constant. We're going to wire this constant to our while loop and then to the case selector of our case structure. So there you go. Now it will turn blue. Now, if I go there, we have only, in our cases, 2 cases. In order to add all the cases, simply we can just right click and say add case for every value. And for now, our default state is the initialization state, and I don't want that. We want our idle state to be the default. So we can just right click on it and say make this case default, and now this is our default state, which is the idle state. Now all what we are left with is to create a shift register for our states. Perfect. And now this is it. Now here, since we have a state machine that runs by itself, we don't need our states variable to be a controller. We need it to be an indicator. So we can go ahead and change it to an indicator, and we'll keep it there for now in order to check what's happening in our code while we're building it, and it's especially useful for the bubble. Now, the first thing we are going to do is to go ahead and start building our reinitialization state. But before that, we need something to work with, which is obviously our interface. So what we need to do is to build our interface. So the first thing we are going to grab right here is a message box in order to display a message for the user. So this is our message right there. Then what we need is a numeric control or indicator. For that, I'm gonna go ahead and choose this one, and here we're gonna type in amount in LBP, or amount in LBP, or you can simply have amount parenthesis LBP. It's exactly the same. Now for our insert money, we're gonna choose the OK button from there. And for the OK button, I can type in here, insert money. And for the label, I need to change it to insert money as well. And now if I switch to my block diagram, I can see now that the label here is insert money. I still have the OK, but that's fine because now I know that this is the insert money button. Now, in order to have a neat interface, what I can do, I can go to visible items and hide the label of this button because I don't need duplicates here in terms of insert money text. Now, what we also need is a indicator. So which is here numeric and a numeric indicator to indicate our balance. And for this indicator, we need the unit here to be displayed in Lebanese font. So for that, we can right click, go to properties, display format, advanced editing mode, and here type in space and LBP. And now the amount will appear in LBP right there. Perfect. Now what we can do is just to format these and make all of them equal in width. This will make our interface really neat and symmetric, at least for the users. So visually it will be really nicer. Okay, perfect. Now we need 4 more buttons, one for coffee, one for milk, one for tea, and one for water. So let us go ahead and create our 4 buttons. So first one we call it coffee. Second one we call it milk. The third one is we call it tea. And the fourth one will be called water. Now we can type in here coffee, and we can type in its price, which is 1,500 LBP. We can type in here milk, and milk is for 1,000 LBP. We can also have our here, of course, tea for 500 LBP, and water is for free. Perfect. Now we have our 4 push buttons. You can design them, choose their size the way you want. So let's say I want them all to be equal in size and height. I can do the following. I can maximize their width and height. And now I have equal width and height buttons. All right, perfect. So let's double check that. Okay, if they are perfectly aligned. Now we need 2 more things. We need the LEDs and our stop and return buttons. So for that, we are going to go ahead and create our LEDs. So the first one will be dispensing coffee to indicate that we're dispensing coffee. We'll have one for milk and another 2. So dispensing coffee, dispensing milk, here dispensing tea, and finally dispensing water. So these are our LEDs. We can distribute them vertically and place them right there. Now what we also would like to do is to have an LED to indicate that we're returning the change. to the user, returning change or balance, and 1 in order to say that the machine or getting ready for your order. So this simulates the initialization state, getting ready to take, getting ready to serve you or to take your order. So let's type in here, getting ready for your order. It's up to you. You can display any, type in any message you would like to. So that's it. And now let's align these two. Perfect. Now there you have it. And then align these two right there. Now 2 more buttons. We need a stop button. So for that we can go to the Boolean. We're gonna have our stop button right there. We're gonna just rename it with a capital S, hide the label, and then we're gonna grab this one and we're gonna say here return change or return balance, same thing. So return change or return balance, and then I'm gonna go ahead and hide its label. And now we have our 2 buttons. Now if you'd like to have similar color here, you can either duplicate the stop button or choose the text right there for the return balance and change its color from there. So it's exactly the same thing. For example, now they have the same color. So it's up to you. Perfect. So let's just drop these a little bit in order to have everything aligned. Place our stop button right there. Okay, and then move our return change button a little bit. Okay, and then we can move these, and now we have our interface. Now, of course, if you would like to design it furthermore, you can go to decorations and add some decorations right there. For example, I can add this decoration right there underneath these ones, and I can move it to back and have my decoration right there. I can also have one for my stop buttons, move it to back, duplicate it, move it to back, and have it right there. So it's up to us. Also, we can have our old dispense coffee wherever right there. We can also duplicate it, have some nice visuals. So here we're opting for a just normal interface. You can have a flat one and you can design it the way that you like. It's your machine, it's your product. You decide what you want to do with it. So for example here, these don't look really nice because they are not aligned. So let's align them a little bit. Okay, extend them a little. Okay, so we can click and shift, select both and make sure their width is the same. And now we have, there you have it, we have our interface. We can create one more, drag it all over, send it to back, and now we have our interface that is ready to be programmed. Perfect, so this is our machine. Now what we are going to do is to go to Window, Block Diagram, and organize our variables right here. So we have the message, we have the amount in LBP, we have the balance, we have our push buttons, we have insert money, we have coffee, milk, tea, and water. And what we have here is dispensing coffee, dispensing milk, dispensing tea, and dispensing water. So as you can see here, we typed dispensing twice, so we need to correct it. We have the return change LED and getting your order ready. Finally, we have the return change button and the stop button. Now, all of these, we can just view them as icons. And what we can do is just to place them here neatly in order to have a very neat interface. So let us align them and let us distribute them vertically. Same thing applies to these. Let us align them and let us distribute them vertically. And for these as well, we can just place them here. All right, align and distribute vertically. And now we have a nice, neat interface. Perfect. All right, and we're ready to go ahead and start coding. So the first thing we are going to do is to initialize our machine. And remember from our state diagram, what we need to do is to clear the amount and balance. So for that, we can go ahead and create a local variable for our amount and insert here, create a constant and insert a zero into it or feed it the zero number. In other words, we're clearing out our amount and we need to clear out our balance. So for that, we can just copy this one, choose balance right there. I also like to align everything. So it needs to be a practice to have a really neat code. Now for the initialization, what we can do is to wait, for example, for 3 seconds and flash an LED whenever we want to initialize our code. So here, if we go back to our given, what they told us is initialization LED. This virtual LED indicates that the machine is initializing and reinitializing to take another order after a certain one. So, for example, we can blink the LED. So let's go ahead to our LabVIEW code. And what we are going to do here to just simulate a blinking, we can choose the elapsed time. And perhaps after 3 seconds, we need to just go ahead to the idle. So here we can go ahead to the comparison. And whenever the time is greater than 3 seconds, what we want to do is go ahead to the idle state. So for that, we can choose the comparison, select, and here go to the idle state. So once it's true, is the time greater than 3 seconds? Yes, go to the idle state. Otherwise, stay in the initialization state. Perfect. So now, there you have it, our idle state. And for that, we can wire our the output of the select operator to our shift register. And now what we are going to do is this state, we are going to just drop it there in order to monitor the states as we run and debug our code. Now what we need to do also is to flash our LED for 3 seconds. So for that, we can just duplicate our elapsed time right there. And for that, we can double click on it, reset it to 1 second, and then just choose here if the time is less than or equal to, let's say, less than or equal to, create constant 0.5 seconds, please flash our LED. So for that, we will choose our, where is it? Getting your order ready. So for that, we can right click, create a local variable, and we can directly wire it to our order. But what we need to do is to display a message that says getting your order ready as well. So we can do that very simply by here. What we are going to do is to, of course, have the flashing LED right there. And what we can do is to have a case structure, place it right there. And for that case structure, what we are going to do is to create a local variable for our message and type in here getting ready for your order. Perfect. So now there you have it. Now let's say we want to test our code. Of course, for now we can't test it because we have the tunnel missing assignment. But what we can do in order to test our code on the go or as we go, we can just choose here use default if unwired and get our stop button and just stop our code directly for now in order to be able to debug our code. Now if you go ahead and run our code, you can see the LED is flashing and we'll get a message right there saying getting ready for your order. Perfect. Now, of course, we'll keep going since there's nothing to do. So after the reinitialization, we haven't updated any of these. Now, here what you can do is for the getting ready order, okay, you can just say it's false, flash it, if not, do not. All right. So let us go now to our idle state. In our idle state, what we need is an event structure. And in this event structure, what we are going to do is to wait for an input from the user. Now for the timeout, we can have simply a 20 milliseconds timeout, which works perfectly for our state machine. And whenever we are in the timeout case or event, what we want to do is simply to go to the idle state, which is our default state. So back to idle always whenever, which means it's our default state. Now next, what we need to do is to go ahead and insert an amount of money. So the first thing we're gonna do is add an event case, choose here the insert money button, and whenever its value changes, we need to execute this event. So whenever we're here, what we are going to do is to go ahead and go to our insert money state. And in our insert money state, what we need to do is first to check that the amount is valid, which means it's a multiple of 500 and greater than 0. So for that, we can grab the amount, create a local variable, change it to read, and what we can do is go ahead and divide this amount by 500. Now, if the remainder is equal to 0, it means it's a multiple of 500. So what we need is two things. We need it to be an amount that is a multiple of 500, and it needs to be greater than 0. So what we can add also here a comparison that says greater than 0. So it needs to be greater than 0. So if it's greater than 0, it's amount. Is it greater than 0? Yes. So for that, we need an AND gate. So both of these must be true in order for it to execute. If it's true, both of them are satisfied. What we need to do first is to add the balance to our, or update our balance and declare the amount. For that, what we can do is, again, have our amount, duplicate it, have our balance right there, and we can add to our balance, already available balance, which is in the first, whenever you first, before inserting any amount of money, it's just 0. Then I can copy this one, change it to right, the balance, and then update it. Now, next, what we need to do is to clear the amount. So I can, again, create a local variable for the amount and just here insert a 0 into it. But the problem with this piece of code right now is which piece of code here must be executed first. Actually, we don't know. It's random. And LabVIEW doesn't know. It will happen randomly. In order to force an order of execution, which means to execute this part first and then this one, what we can use is a flat sequence. So in a flat sequence, we will first here update our balance, and then if we right click there and a frame after, add a frame after, we will then clear our balance. And now once this is done, once our balance is cleared, or once our balance is updated and the amount is cleared, then we need to proceed and go to the idle state. So for that, we can copy our enum right here, states enum, and update our state. Perfect. So now we want to go to idle, but before that, what we want to do as well, we want to display a message for the user saying that please enter or choose an option, for example. So here we can type in please select an option, since the amount now is valid. Please select an option. Now this all will happen in case this is satisfied. In case this case here is satisfied, which means we are in the true case. If not, what we need to do is to prompt the user that we're gonna again go back to idle, but this time we wanna prompt the user and tell him or her that the amount is invalid. Please enter a multiple. Amount is invalid, for example. Please enter a multiple of 500 LBP. And now we have what we need. So let's go ahead and debug our code, run it and check it. So if we are in the true case, we'll update the balance, clear the amount, and then clear the amount. Okay, let's place this one right here. It looks nicer. Clear the amount and go back quickly to idle to wait for an input, whether they need coffee, milk, tea, or water. So let's run the code. So what we are going to do first, let us type in here 5,000, insert money. Our balance is updated. Please select an option. Let us type in here 720 and insert money. Amount is invalid. Please enter a multiple of 500 LBP. So now our code is working perfectly fine, and that's great. Now what we need to do is, since we are done with the insert money, we need to go ahead and back to our idle state and to code what will happen, okay, whenever the coffee button is pressed. Now, here one thing we've missed is to hide the labels of our buttons. We don't need them, so we can just hide them and we will have a neater interface. So we can have them like that, perhaps, or let's keep them like that. Okay, we can make them larger, right? Okay, so let's select all of them and increase them with their widths. Choose this one. All right. Now, what we are going to do is the following. We are going to program what will happen whenever the coffee button is pressed. So for that, we can go to our event structure and add an event case. And for that, we will choose the coffee button, which we called coffee. Here, you need to make sure that your LEDs and your push buttons, they have different namings. Otherwise, you will confuse them whenever you're working with your event structure. So we're going to type in coffee. So now whenever coffee is executed, the first thing we're going to check is the balance. If the balance is available, we'll proceed to coffee. If not, we will prompt the user. So here, what we need to do, check balance. If enough, proceed to the desired state. If not, we need to prompt the user. So let's go ahead and do that. So for that, what we are going to check is our balance. So we're going to have a local variable right there, and we're going to change it to read. Now what I like to do right here is just to have these on this side. Okay, and these as well. And these as well. Because it's a good practice to always have your LabVIEW code in just one window. You don't need to scroll back and forth. All right. So what we can do is to just place these right there, get these and place them right here. All right, perfect. Okay, so now we're gonna check our balance. So if our balance is greater than 500, 1,500 LBP, is it greater than 500, 1,500? That's great. We're gonna go ahead and proceed to our coffee state. So for that, we can grab the initialization right here, say dispense coffee, and then wire it to our coffee, to our shift register. Now, if not, what we want to do is create a constant right there and say go back to idle. Now, in the coffee state, dispense coffee, if it's false, if the amount is invalid, we need to prompt the user. So again, we can grab a local variable for our message, right click, create a constant and say insufficient funds for coffee, for example. insufficient funds. Please insert, or just insufficient funds for now. Let's keep it short. So insufficient funds, and if not, we'll proceed to dispense coffee. So let's go ahead and run it. So let's say here, getting ready for your order. Now let us enter 2,000 Lebanese pounds. Let's stop our machine, rerun it again. We need to enter an amount that is less than, for now, for testing. So 1,000, insert money, insufficient funds. Perfect. Stop. So now we have it, insufficient funds. Okay, so now in case we have sufficient funds, what we need to do is to dispense coffee. Now for dispensing coffee, here's what we are going to do. We are going to dispense coffee for 5 seconds. So for that, what we are going to do is to go ahead and grab our elapsed time. So this elapsed time here, it simulates a sensor in a project that you have. It can be a water level sensor, a liquid level sensor, a load cell that is measuring the weight of the cup with the liquid to know when you want to shut down your valve. It can simulate a signal from a computer vision camera or a source. So it simulates a sensor. For now, for the sake of simplicity, we're going to use a elapsed time to simulate the dispensing in terms of time. So we're dispensing for 5 seconds. Now what we are going to do here, we are going to say if the time is greater than 5 seconds, if it's greater than 5 seconds, the time, because we're dispensing coffee for 5 seconds, what we need to do is to simply, once the time is greater than 5 seconds, we need to stop dispensing. So for that, we're gonna grab our dispense LED, and this is our dispensing coffee. Let's double check it. Yes, this is our dispensing coffee LED. Create a local variable, and for it, we're gonna create a constant and set it to false. And once we're done with dispensing, what we need to do is to go back directly to the idle state. Simply. Now, before we go back to the idle state, because we dispensed coffee successfully, we need to check the balance or recheck the balance, remember. So what we need to do is to subtract the amount of 1,500 from our balance. So for that, we can grab a local variable again, change it to read, subtract the amount, which is $1,500. So create a constant, $1,500, and then place this amount in our balance. And now we can change it to right and update our balance. So now our balance is updated accordingly. And here we can also have a message for the user saying, please choose another order or take your change, for example. So please select an option, for example, select an option, or take your change, if any. Okay, the user might not have a change, or the change might not be there. So getting your order, idle, insufficient funds, perfect. Insert money. Let's go ahead and check the insert money. Okay, true and false. We're just here making sure that we don't have a period at the end of our sentences to be consistent across all messages. Perfect. So now coffee value change, we go to dispense coffee. Now this is in the false case. What we want to do is we want to update the balance and go back to idle and turn on our LED. What about in the false case? In the false case, we need to turn on our LED, which is the dispense coffee right here. We'll change it to true. We're going to create a constant right there, and we're going to stay as long as the time is less than 5 seconds, keep dispensing coffee. And that's what we have seen here. This is the green arrow right here. It says if time less than 5 seconds, keep dispensing coffee. So we need to stay in the same state. And for that, what we want to display here for the user as a message that we are dispensing coffee, and we want to have a countdown of 5, 4, 3, 2, 1, and 0 seconds. So for that, we can just create again a local variable, And in order to simulate the time, we can grab a constant right here and subtract from this constant the elapsed time in order to have our countdown. So we can subtract right there 5, for example, since we are dispensing for 5 seconds, minus the elapsed time. Now, since we need the elapsed time to be displayed right here as an integer value, I can just convert this double value to an integer value easily using my conversion element right there. And then what we need to do is to have a constant here, string constant, saying dispensing coffee, dispensing coffee, and we can type in or place the time right there. For that, we can use the format into strings. So the format into strings function, its first input will be a string, and then it will convert this numeric number here to a string and concatenate it directly into add it or concatenate these two converted numeric into string. It will be concatenated to our dispensing coffee string. Then what I like to do is to display the unit for the user because it looks nice. So we can use the concatenate string function. And for that, we can just here create a constant again. And in this constant, we can type in space and S. So space just to have a space between the number and the unit. And finally, we're gonna place wherever is there in our message local variable. Now, there's one major problem with this code. It works fine, as we will see, but it's this elapsed time. This elapsed time, it won't reset when we enter for a second time. In other words, what about if I wanna order coffee twice? All right, so the elapsed time will keep going. It won't be resetted. So for that, we need to reset it ourselves, and we will see how. So let's first of all run our code, getting ready for your order. Everything is working perfectly. Now let us type in here 5,000, insert money. Now we have 5,000 Lebanese pounds. Now, if we go ahead and dispense coffee, it says dispensing coffee in 5, 4, 3, 2, 1, 0 second. And now please select an option or take your change. For example, if I want to dispense coffee again, let's go ahead and dispense it. As you can see, it didn't work properly. Why? Because the elapsed time, it didn't reset. For that, we need to reset it ourselves. So for that, we can just go ahead and grab a constant, which is a true constant. So whenever we are getting out of the loop, we want to reset it. So for that, what I'd like to do is to have go to Boolean, choose a true constant right there, wire it to my input. Then we can go to structures and have a feedback node. So because I'm feeding an output back to the input, what I want to do is use a feedback node, and there you have it. Now I have uh, my elapsed time block reset. Now, in case we are in the false case, all what we need to do is just to create a false constant. And we can just place this one right there, and there you have it. Now, let's go ahead and try something. Let's run our code again, enter an amount of 5,000, insert the money, order coffee, dispensing in 5, 4, 3, 2, 1, and 0, and dispense again. So now I can order multiple times. Perfect. Now I can order for a third time, and you can see the state here. It says dispense coffee. This is why we need it for now. Now, if I try, it'll say insufficient fonts because we don't have the required amount of fonts. And that's it. That's pretty much it for our coffee state. Now, for our other states, it will be exactly the same. So what I can do is simply you can either duplicate the case or I can just get the code and place it right there. So for me, it's easier to just get this piece of code, copy it. Okay, perhaps not there. Okay, let me undo this one. All right. So what I'm going to do, I'm going to copy this piece of code, place it there. And then all what I'm going to do is I'm going to go to dispense milk. And for the dispense milk, I'm going to grab this one again, copy it and place it there because I need exactly the same piece of code. But instead of 5 seconds, I need 4 seconds. And in the false case, instead of dispensing coffee, we need dispensing milk. And in the true case, we need dispensing milk as well. And we need to update the balance. We need to subtract only 1,000 because it costs 1,000. Perfect. Now in the false case, instead of coffee, we need to type in here dispensing tea. And once we're done, we need to stay in dispensing milk. Actually, it's milk and not tea. So milk, milk. Perfect. So here we need to type in milk. So dispense milk. If not, stay in the idle state. And that's it. Now for the dispensing tea, we can do exactly the same. Grab this piece of code, press the control button and drag it upward. So never use copy paste in LabVIEW. All right. So there you go. Now we're gonna wait for 3 seconds for T. We're gonna update our balance by subtracting 500 and not 1,500 or 1,000. For dispensing coffee, we'll have dispensing T. In the false case, we'll have dispensing T. And here we're gonna type in dispensing T, and we're gonna stay in the dispensing T case as long as we're concerned with dispensing T. Now, we want to do is one final one, which is dispensing water. And for dispensing water, what we can do is just connect our idle again, right there, and have our false case dispensing water for or dispense water state. And here we're gonna have 2 seconds, okay? And here we're gonna have dispense water, okay? And here we're gonna just subtract 0, which means it's for free. And one thing that we have missed, I think, perhaps, is this one here. We need to subtract 2 right there in this case. And in the T, we need to subtract. We need 3 minus. And in the dispense milk case, what we need is 4. And let us go ahead and check our code. So let's run it. So it's running perfectly, getting ready for your order. Now let us insert the amount of money, 5,000. Insert money. Let us dispense coffee. Dispensing coffee, 3, 2, 1, 0 second. Dispensing milk. It didn't work. And let's see why. Wow. Okay, dispensing tea, dispensing water. Of course it won't work. Why? Because in the idle state, we haven't put anything. Didn't have a source for our input. So we missed that part. So again, what we need to do is to go to the add event case right here and choose milk. And for the milk case, what we need to do is to have the same thing as for the dispensing coffee state. So we need to check the balance. If we have sufficient funds, we will proceed. If not, we will not. Perfect. So let's do that. So for the milk, we will check the balance. It's 1,000. If yes, stay in the idle state. Go to the idle state. If not, if it's not sufficient, false. If yes, go to dispense milk. The same thing for our next state, which is the T1. So dispense T. Okay, we're gonna go ahead and grab our piece of code right there, put it right there. Now we're gonna go to dispense T if it's true, and the amount should be, is the amount greater than or equal to 500? Yes. Otherwise, just say insufficient funds. One final one, which is for Wora. So for this one, we're gonna add an event case, go to water right there, add it, and for that, the amount should be greater than 0. Actually, you don't need it, but we'll just put it here for the sake of completion. For example, what if you decide that you want to charge for water, for example, 100 Lebanese pounds or 500, just like tea. So you can keep this one here for your record and change it easily if you want to change your prices easily. So dispense water. Now, if we go ahead and run our code, let's run it again and check. So getting ready for your order. Let's type in here 5,000, insert money, dispense coffee. We're dispensing coffee in 543210. Dispensing milk, now we're dispensing milk. We're dispensing tea. And we can dispense water as long as we want. So let us dispense milk again, and it's working perfectly. Dispense tea, and finally, if we try milk now, insufficient ones. If we try tea, we still have 500. If we try tea, insufficient funds. Milk, insufficient, insufficient. Water, you can still, because it's free. And let's stop it. So this is it. It's working pretty nicely for the water. Now what we need to do is to update our change. We need to have a way to get our change back. But before that, I need you to just look at one thing. Whenever I run the code, and let's say we type in here 2000, I insert the money, the button is still pressed and it doesn't pop back. So this is not really cool and not nice on our interface. So what we need to do is to update the value. Now there are two ways. You can either place your indicate your controllers inside the while loop, or what I like to do usually is to do it programmatically. So what we can do is to go to insert copy, go to create, invoke node, and say here reinitialize to default. And now what I have is a nice way to update my variables. And I can do the same for coffee, milk, and tea. So let us go ahead and do that. Let me place this one. He's right there, and the getting ready right here. Okay, align them. I just like things to be aligned. Okay, and now for our coffee, we need the same thing. So insert money, coffee, milk, and tea. Okay, so coffee, right click, create property or invoke node, and reinitialize to default. Same thing with our milk button. Create, invoke node, reinitialize to default. Same thing with our water. Create, invoke node, reinitialize to default. And for our return change as well, create, invoke node, reinitialize to default. And we will deal with the stop button whenever we deal with the exit or stop state. So perfect. Now let's try it. So if I type in here, for example, now once my machine is ready, insert money, it pops up, insert coffee, it stays there. Now if I type in on return balance, of course, nothing will happen since we haven't programmed it yet. Perfect. So now there you have it. Now we need one more to return our change. So for our change here, we can add an event case and we can choose the return change button. And for that, we want to just go ahead and create a constant and go to the return change case. Now for our return change case, all what we need to do is to have the balance right there, create a local variable for it, read whatever we have there, and we want to check if the balance is greater than or different from 0, which means greater than or equal to 0. So we can just check here if the balance. So let's type in here greater than. You can choose greater than or equal to 0, same thing. Greater than or equal to 0, then what we need to do is to return the change. So what we want to do is the following. We're going to have a case structure right here. If the balance is greater than 0, all what we are going to do is to take this balance, change it to read, and prompt the user here, create a local variable, so local variable for our message, and we want to tell the user to take this amount or return it. So in other words, physically in a device, you need to operate a certain mechanism in order to return the change. So for that, we're going to just display a message saying that please take your change of, please take your change of whatever value it is. So we're going to add this one, the balance, okay, and we're going to have here an integer value to avoid having decimal points or zeros after the decimal point. So integer. So now I'm going to grab the balance, add it to it, change of whatever number here, and we're going to add here again concatenate and add the constant, which is create constant space LBP. So take whatever change, whatever value it is in LBP, and display it there. Now, what we need is, if the amount is not greater than 0, we're simply going to tell the user that no remaining money, or amount, no remaining money in your balance for the change. Now, whenever we do that, whenever we're happy with it, okay, whether it's true, if it's true, what do you want to do? This is what we are going to do. If it's false, no remaining money in your balance, and we'll simply go ahead and reinitialize. Now, also what we can do right here is to grab our return change LED. This is why I told you we don't need returning change. Perfect. Let's say different name. Create local variable and turn it, create constant, turn it on true. So if the money is greater than true, and here it's gonna stay in the return change state. So it's gonna stay in the return change money. Now here we can add a time delay or an elapsed time. Let's go ahead and check if this is working efficiently. If not, we need to adjust it. So let us add, for example, here 2000, insert money, let us dispense water, and let us take our change. So please take your change of 2000 Lebanese pound. Now we can see that it's stuck in the return change. It didn't go back. So here the state is return change. So let's go ahead and debug it. Why? Because it's true, it says go, but this is not what we need. We need to just go directly to reinitialization if it's true. So that's our mistake. In both cases, we need to go to the reinitialization. So if we go ahead and run it again and type in here 2000, insert the money, now return a change, and it's back. It goes back to idle. However, we didn't update the message right here, and we didn't turn off our LED. So what we need to do here is in the initialization state, reinitialization, what we need to do is to have a text, okay? So in case it's true, so we're saying here true, which means less than 5 seconds. If it's false, we're gonna always say here in the initialization, getting your order ready. Okay, so it needs to always be there, in other words. Okay, so let's try it again. And we need, of course, to here create constant, returning change, returning money, local variable, and create a constant and turn it off because it's reinitialized. Okay, so let's go ahead and try it. 2000, insert money, return change, getting your order ready and cleared out. As you can see, what happened here is that the return change state, it happened, but it happened really quickly. So what you can do is to add a timer for that. Okay, so as long as, so how are we going to do it? This way. Okay, so what we are going to do is have an elapsed time right there. So what we are going to do, choose the elapsed time. And here we're gonna say, for example, I wanna return the change in 5 seconds. Again, this simulates a sensor or whatever. Okay, so it is greater than or equal to, for example, create constants, 3 seconds. Okay, if it's greater than 3 seconds or less than, let's replace it, and I will tell you why in a second. So if it's less than 3 seconds, okay, we're going to delete these two right here, Control B. Okay, perfect. Because we don't want to just go quickly. The user doesn't have enough, won't be able to see the message or wherever. So what we are going to do is the following, is to just say the time is less than 3 seconds and the balance is greater than or whatever than 0. Okay, what we are going to do, okay, less than 3 seconds, we're going to select our select operator right here. Where is it? Our select operator. We're gonna go to our state, which is the less than. We're gonna stay in the return change for sure. And if not, we're gonna go back to our reinitialization. If it's greater, go back and reinitialize our state. Perfect. Now, let's go ahead and try it. So let's run it, reinitialization, enter an amount of money, which is 2000, insert the money right there. Now what we are going to do is say return balance. Now it's returning the balance, which is of 2000 pounds. Perfect. Now if we try it again, let's type in here, insert 5000. I want to return the balance, nothing happens. And that's what I want to show you right here. Why nothing happens? Because what's happening right here is that our case structure is not updated or is not updated. In other words, we did not reset our elapsed time. So for that, we need to reset it as usual. So what we can do here, we can delete this case selector right here, delete these two, we can have a case structure, and here what we can do, if it's less than 3 seconds, is it less? Yes, stay where in the return change state. If not, go to the reinitialization state. Perfect. So stay in the return change. And for that, what we need is, as usual, a feedback node, as we talked about. So I can just wire it directly and the feedback node will pop automatically, or you can grab it again. So if it's false, go to reinitialization, but true. If not, do not reset it here. So just reset it before you exit. Now what we can do is the following. We can run it again to make sure our code is functioning properly. So let us type in here 2000, insert money, return my change, returning your change of 2000 pounds. Now back to getting your order. Now what we need to do, and still here you didn't see the LED flashing for the same reason. We didn't initialize our elapsed time. So here we can grab again 2000, return your change, and it works perfect. So this is why we need to always debug our code. For example here, perfect. So this piece of code now is ready for us to work with. All right, so let's just move this part and place it right there. But there's one problem with this piece of code right there, which is the greater than or equal to 0 comparison right here. We need this case to go to false whenever the balance is equal to 0 to tell the user that no remaining money in your balance to be taken. So for that, we want to just replace the greater than or equal to 0 by just strictly greater than 0. And now what we have is that if the value is greater than 0, which means there is enough balance there, the change will be taken. If not, it will simply display whatever we have in the false case, which is no remaining money is in your balance. And now if we go to the reinitialization, we did not reinitialize here this timing. For this one, it's perfect. We don't need to worry about it because it automatically resets. But for this one, we need to always reinitialize it. So for that, I can just move this one a little bit downward, and we can just grab a feedback node. Okay, and let's see if it works without a case structure. So we're gonna go ahead and reinitialize, enter an amount of 2000, return the change, and now it reinitializes as we want. Perfect, it's working perfectly. Now our code is working perfectly. One more thing we need to do is to stop our code in case we want to do that through the idle state. But before we do that, there's one thing I want to stress on. Here, whenever the code is running, I can still enter a number while it is being initialized. For example, let me stop it and quickly enter here 1000, and it will clear out to 0. Now here what we can do is we can restrict the user from entering any amount or inserting any amount of money while the machine is initializing programmatically. And how can we do that? It's super simple. What we need to is to go to the amount right here. We can right click, go to create property node, and here I can change many of things programmatically in LabVIEW. I can change the size, the position, whether I want to hide, you name it, whatever you want to do. So you can explore all of these functions right there. But one of them that is really interesting is the disable one. So let's find it. So here, for example, it's the disabled. So what I can do right here is in the initialization state, I can grab this property node, I can right click on it and say change to right, and then create a constant. And what I want to do is I want to disable this one in the uh, initialization state, plus I can gray it out. So let's go ahead and try this one. And then what I want to do next is I really want to enable it whenever I am in the idle state. So whenever I am in the idle state, which means right there, what I can do is to just place it here. And then now I have it and it will be enabled afterwards because I just passed the initialization phase. So let's go ahead and try it. So if you try it now, you cannot press it. Okay, there's nothing. Now let's say you don't want to gray it out because I think it doesn't look nice. At least for me, it's up to you. So let's go ahead and just do something. Okay, I want to undo it here because now it messed our code. And what I want to do is go to the idle state, just put enabled right here, and then I'm going to go ahead and place it there. Perfect. And now if I go ahead, stop. Okay, we didn't change it actually. It should be disabled. All right, and what we can do is run our code again, and now I cannot enter anything while the code is initializing. Now, once the initialization stage passed or the state, now I can do whatever I want and do whatever. And you can do the same for other buttons as well if you would like to do so. So taking my change, and now I'm stopping my machine. So again, getting ready, I cannot do anything with it. Okay, while it's initializing. Now what I want to do is one more thing here. What about if the user enters a negative amount? We can also go to the data entry right here, and we want to set the minimum amount to 0. Now for the increments, you could have forced the increments of 500s instead of having the remainder function directly here. You can just type in here 500 and force it to be, where is it? Force it to be 500 in terms of increment, and you can quarter it. But the problem with that is you cannot display a message. You want to do that programmatically and display a message. So for us, we'll just keep it, ignore, and keep it to 0. But for the lower limit, we need it to be 0. So no negative numbers are allowed in the machine. And that's pretty much it. Now, all what we want to do now is to grab whatever we have in terms of data and feed it to our remember myRIO, and then we want to get data back from the myRIO through the push button back to our PC. So let's go ahead and do that. And for that, what we need is to create shared variables. So again, I can just here insert, go to numeric or create shared variable node and new shared variable. And for that, it will automatically be named as states. Perfect. So now there you have it. Now for my local variables, for my dispensing coffee, milk, and tea, I can go ahead and create local variables for my LEDs, and I can change them to read. So I have dispense coffee, I have the dispensing milk. If you want to verify, just double click on it and you can do that. I'm going to copy these two, place them right here, dispensing tea and dispensing water. And now what we want to do is to create 4 shared variables for these. So I'm going to go ahead and create a shared variable node, new shared variable. Here, create shared variable node, new shared variable. Right there as well, create shared variable node, new shared variable, and here create shared variable node and create a new shared variable. And now there you have it. We have our shared variables. Now what we need to do is to transmit this data to the myRIO. Now if we go to the project, again, we see that our shared variables are created underneath different libraries. We just need one. So I'm going to go ahead and drag and drop them underneath one library, then remove these. So we have milk, coffee, tea, and water, and we'll just discard these. Remove from project. Okay, don't save all. Now again, remember, for our library to work, it needs to be underneath the myRIO target. And we're gonna say save all right here, go to desktop, vending machine, and say here my variables. Type in my variables to save them, and now I have them. All right, so this is our, okay, so what happened? Okay, let's check. Desktop, my variables. My variables, another library in the memory is already loaded. Okay, so let's call them vending machine variables. Perfect. So now we have my variables, vending machine. Okay, we don't need this one. Remove from library. Okay, don't save. These are my variables. Okay, and this is our VI, and we haven't saved it yet. Let's call it here vending machine PC interface, and let us save it. Why do I have here this one? Okay, variables. Let's go ahead and save it. Shouldn't have such a thing right here. Okay, for the main here we don't need it underneath the target, and perfect, this is it. Now we can save our project and we can run it again to make sure everything is running smoothly. So now everything is being deployed, and what we need to do next is to go ahead to myRIO and get the data. So for that, we can create a new VI underneath the myRIO target, save it, and say vending machine, type in here myRIO. Perfect. So now what we are going to do is the following. We're going to create a while loop, create a controller right there with a stop button. And next, we're gonna go ahead and grab our local variable from structures and then select for these our states local variable. And for our states local variable, we're gonna just feed this data directly to our case selector and choose add case for every value. And now there you have it, we have all of them. Now for us, we need to turn on the LEDs on and off. So but we can do that through the LED blocks right there. We need 4 LEDs. So what we can do is to just wire these 4 to the tunnel right there. So let's do something. Let's copy this one first. Shared variables and myRIO, and have here dispensing coffee. Copy, copy, copy. Perfect. So now we have dispensing milk, we have dispensing tea, and finally dispensing water. Now let's align these nicely right here. And what we need right here in the idle state, actually, we don't need anything. We just need a false constant, right? Or we can right click here and say use default if unwired, but now it won't work because it still doesn't know what's the data type. So let's go ahead and in the dispense coffee, we know that we want to transmit, we want the coffee LED to be on. Okay, in the milk, we have the tea, and finally we have the water LED. Perfect. Now, in the reinitialization or whatever, I can just right click and say use default if unwired, use default if unwired, and use default if unwired. Now, this is in our insert money also. In the dispense milk, we want the 4 structures. So what I can do is go to dispense milk, wire them again. So dispense coffee, we'll get the data right here, dispense milk. So the others will be false and the dispense coffee will be on. Okay, now if we go to the dispense tea, same thing, we'll grab the data from there. Okay, all right, we'll have the milk, we'll have the tea, and we'll have the water, and one final one, which is the water, and there you have it. We'll have our coffee, our milk LED, tea, and water. Now, what we can do is just add a small timer, as we discussed last time, in order for the NI myRIO to be able to process the data. So this can be a just 5 milliseconds timer, and on our PC code, we can also add another timer, which is around a little bit larger, around 20 milliseconds, just to make things that the data flow is smooth. So now let us go ahead and first of all, run the myRIO code that we have right here. So let's run it, make sure it's working properly. And then let us go ahead and run our PC code. Now our PC code is running, and what we are going to do is to see here our myRIO, and we want to check it side by side with our VI right here. So let's put it on one side, and let us put our myRIO on the other side to see them side by side. Now let's say we want to dispense coffee. So first of all, we're going to insert 5,000, insert money. Please select an option, dispense coffee, and as you can see, the LED lights up on the myRIO. We can dispense milk, the second or LED one will turn on, which is the second LED on myRIO. Dispense tea, the third LED will turn on the myRIO. And see here, we didn't change it for the tea, and water didn't pop back. We'll have the fourth LED. So let's go ahead and try tea again. Perfect. Now let us go ahead and stop our code and see why the tea didn't pop up, because we missed it. Okay, create property node, invoke node, reinitialize to default. And now we have it. So let's run it one more time to see it, see how nice it is. So it's getting ready. I can't enter anything here. I am rushing to 2,000 Lebanese pounds, dispensing tea, it pops back. Now, if I want to return the change, it's returning the change of 1,000 LBP and then getting my order, getting ready for the second order. And finally, I can stop it. Now, what I need to do right here is for the stop button, I just don't want to, perhaps I can keep it right there if I want to directly get my value, okay, or stop it at any time. Okay, stop, but this is not a good practice if you have a machine by itself. You don't want the user to be able to stop it midway. But for us, as the programmer, you can do that, just to show you different ways of doing it. And now what we're gonna we are going to do is to go to our idle state, add an event case, and for that we're going to choose the stop button. We're gonna, and whenever we click on it, its value changes. We want to go to the stop case, and in our stop case, what we are going to do is to go ahead and grab a true constant and feed this true constant to our conditional statement. And now I can just right click and say use default if unwired. I can either keep my stop button inside to keep it to update it at any time, okay, just like the initialized case, or what you can do is, if you want to create a local variable, you need to change the mechanical action. For example, here you can change the mechanical action for your stop button, and you can retrieve the same on the front panel. Whenever you create a local variable for your stop button, it won't work with the latch here mechanical actions. You need to go back to switch when pressed, released, or until released. So you will always get an error whenever you create a local variable for it. So now, whenever I run the code, and if I just type in on stop, it will stop. And now this is now through my state. Now there's one more thing before we wrap up this session, is to be able to return the change either through the push button here, which is the return balance or our interface, or by simply pressing the button on the NI myRIO. And to do that, what we are going to do is to first go to our VI right there, which is the myRIO VI, and grab or retrieve the data from the push button of the, or the physical one. So we're going to go ahead and grab the button right there. I can call it here return change myRIO, right? And now I have it. Now all what I have to do is to create a shared variable and a new shared variable. And now it will pop up where? Right there on my, underneath my library. Now again, for that, I need just this one to be right there. Okay, and I can rename it and say here, return money, myRIO button. And simply remove this library because I don't need it. Now we can go ahead back to our PC and retrieve the data from that. Now what we are going to do is simply go to the idle state right here. And in the idle state, in the timeout, okay, what we are going to do is to keep checking whether the push button is pressed, yes or not, through myRIO. If it's pushed, it means please return the money. So to do that, we're going to go ahead and copy this shared variable. Access mode will change it to read. Click on it, and here we want our return money. Now, if this return money is true, what we are going to do is to go ahead and go directly to the return money case in the idle state, in the timeout state. So if it's true, please get me to the return money state. If it's not, just as usual, go back or return change or return money state, okay, or return balance. If not, please go ahead as usual to idle. So everything will stay the same. So I can just wire it right there, and there you have it. Let's go ahead and try it. So now let us have our myRIO in front of us just to see it in action. It will be nice. So we have let's run our code, and let us make sure we're running the myRIO code to be able to retrieve the data. Save everything, run this code. Now everything is working fine, getting our money ready. Let us insert here 5,000, insert money, copy, first LED is on, just to see it again in action. Water, for example, we still have 3,500 pounds. I can return the change through my virtual push button. Getting ready again. Let us insert 500 Lebanese pounds again, 5,000, and then buy, for example, tea. And now we're gonna go ahead and press the push button right there on myRIO. So let's push it. And you can see now it's returning our change of 4,500 Lebanese pounds and then reinitializing our myRIO. And now I can stop my code. Now what I want to do next is we want to build a PC application that runs independently from LabVIEW, and we want to deploy the code on the NI myRIO to be able to run it on startup without opening LabVIEW. And that's something pretty cool. So let us go ahead and close all of these. So what we are going to do here next is go ahead and let us see what's happening right here. Okay, we need a little bit of space. Let us put this one right there. Okay, close this VI, close this one as well, save it. And now let us go ahead to our project palette. Okay, so in our project palette, what we are going to do is the following. First of all, we are going to go to our vending machine, and underneath our host PC, we're going to go to build specifications. And for that, we can create a new application or PC application. We can specify the name. We will call it vending machine. And I can choose the location or directory. So for that, it can be in this folder, current folder. And for the source file, it needs to be our vending machine VI. Then we're gonna go ahead and build our machine. And now, if you notice, if we go to desktop right there, to our vending machine, now I have my application right there, which I can open and run. So now this is an independent, it's not a VI anymore. Again, it's just a machine and I can do whatever I want. So for example, I can stop it, etc. So now it's stopped. All right. So by the way, here we missed something. For example, you can display a message that machine is off whenever we press the stop button. So we can do that. So let us go ahead and do that just for the sake of completion. For example, whenever the value stop change, you can go to the stop button right there. I can create a local variable right here. Let's say create constant machine is off, or this vending machine is off. So let's go ahead and try it quickly. So run it and then stop it. Of course, it can now it's reinitializing. This vending machine is off. That's pretty cool. Now, another thing I want to stress on that perhaps this one was used for debugging here the states, and now we don't need it on our interface. So we can go ahead, right click on it, and say hide indicator. And now if I double click, you will see it's still there, but it's not shown for the user, and that's something pretty useful. So let us go ahead and build our machine again. Okay, done. So you can open it from, run it from there as well. You don't need to go to the folder. And there you have it. This is our machine. And if we stop, our vending machine is off. Now what we are going to do next is to go to build specifications underneath the myRIO, go to real-time applications. And for that, we're going to call it vending machine myRIO. And for the source files, we need the VI, and for the additions, we need our variables. Now we're gonna go ahead and build it, and then we're gonna deploy it. Okay, let's see why. Okay, build. Okay, details. Okay, perhaps we need a destination there. Let us go ahead and remove from project, okay, and build again. So real-time application. Okay, we didn't specify the location. So vending machine, current folder. Let's call it vending machine myRIO. Source files, we have the, and for the libraries and source files, and that's it. Now I can build it successfully. Let's try it. Perfect, it's working fine. Processing. Now it's done. Now here's what I want to show you. So here, what we have is the following. So now what we are going to do is to have our machine here deployed. So we're going to deploy it. Okay. And then we're going to say here run as startup. And as you can see now, it will say the myRIO needs to reboot in order to load it and deploy it. So we'll see now that the status here, the status LED will turn into orange, stating that the myRIO, or showing us that the myRIO is rebooting because it's loading the VI or deploying the VI and libraries. So as you can see now it's rebooting. So let's wait for it. Perfect. So now all is good. And the code now is running by default my on the myRIO. Now I can save all and close. I don't need any more to open myRIO to open LabVIEW in order to run the code. Now simply because the myRIO is now on, the code is running on it by default on startup. Now I can go to desktop to my vending machine and open my application, which is no longer a VI. So now I don't have LabVIEW is not there. It's just an application. And now I can type in here any amount of money. I have a PC application. I can order coffee and it communicates directly with the myRIO without us opening LabVIEW. So for example, here we can close LabVIEW just to show you. So now we have closed LabVIEW and you can still order milk and everything will function. Now for this application, for this scenario, we still have the myRIO connected to the USB cable, but we could have connected the myRIO via Wi-Fi from the beginning, and then we could interact easily with the myRIO through Wi-Fi. So we don't need our myRIO to be tethered to the laptop. Imagine if you have a robot or wherever, and you need an untethered device. So you can do that easily with the myRIO. So now we can return the change and it will go back and reinitialize. And finally, we can stop our machine. This is it for module 5. And this is it for building state machines in LabVIEW.